Let's move on to question C. We start with forward substitution. Here, instead of subtracting, we divide n by 2 each time. So let's start with the base case first. T of 1 equal to 1. Then we need to find T of 2. So T of 2 equal to T of 2 over 2 plus 1 equal to T of 1 plus 1. So T of 2 equal to, we substitute, then we get 1 plus 1 equal to 2. Then we find T of 3. But here, as you can see, we get T of 3 over 2 plus 1. We can solve this. So we just move on to the next. T of 4 equal to T of 4 over 2 plus 1. We simplify it, will be T of 2 plus 1. We can substitute this. Then we will get T of 4 equal to T of, oh no, I'm sorry. So we will get 2 plus 1 equal to 3. So we can see the pattern here, 2, 4. Maybe we can try T of 6 or T of 8. So I will just T of 8 since we want to divide by 2 here. We don't have T of 3. So T of 8 equal to T of 8 over 2 plus 1 equal to T of 4 plus 1. So we have T of 4 here. We can substitute T of 8 equal to T, I'm sorry again. So equal to 3 plus 1 equal to 4. So as you can see here, you can see the pattern here. Each time n double, okay, n double, 2, 4, 8. You can see the pattern is 1, 2, 3, 4, increase by 1. So this is a, we can see the pattern here. This is a logarithmic pattern, log pattern. So the answer is T of n equal to log n. So BO is log n. Let's move on with backward substitution. We start with this equation, T of n equal to T of n over 2 plus 1. So we need to find T of n over 2. So T of n over 2 equal to, we substitute n over 2 into the first equation here. So we get T of n equal to per 2 plus 1. So we simplify T n over 4 plus 1. We substitute this into this equation. We simplify it, will be T of n over 4 plus 1 equal to T of n over 4 plus 2. So next, we need to find T of n over 4 equal to T of n over 4 over 2 plus 1 equal to T of n over 8 plus 1. Then we substitute this. Then we simplify, will be T of n over 8 over 4 plus 2. We will get T of n over 16 plus 3. So we can simplify this. T of n equal to T n 2 over k plus k. So we start with the base case next. We want to substitute the k here. So we need to find n over 2k equal to 1. So we will get n equal to 2k. We need to simplify it, will be k equal to log n. Then we substitute log n into k, and this using this. So we will get T of n equal to T1 plus log n. So T1 we substitute with 1 plus log n. So the conclusion is T of n equal to log n plus 1. So we will simplify it and get the BO log n. Let's move on with question 2. Set up the recurrent relation for the basic operation and find the BO of the following algorithm. So based on this algorithm, this function calculates x to the power of n. If n is 0, it's written 1, which is the base case. Otherwise, it multiplies x with the result of power of x and n minus 1. So each recursive call reduce n by 1 until it reaches 0. So this is the base case. T of 0 equal to 1. Then we have the recurrent relation here. We have multiplication. And we also have recurrent relation. So we have T n minus 1 and also we have plus 1. So when we set up with the recurrent relation, we get T of n equal to T n minus 1 plus 1. So we need to find T n minus 1. So here I use backward substitution. So T n minus 1 equal to T n minus 1 plus 1 equal to T n minus 2 plus 1. So we will get this and we substitute into this formula, then we will get equal to T n minus 2 plus 1 plus 1. Then we simplify it, will be T n minus 2 plus 2. Then we need to find T n minus 2. So T n minus 2 equal to T n minus 2 minus 1 plus 1. We will get T n minus 3 plus 1. Then we simplify, we substitute equal to T n minus 3 plus 1 plus 2. We will get T n minus 3 plus 3. So when we simplify it at k step, so at the k step we will get T of n equal to T of n minus k plus k. So at the base case, we get the base case earlier. The base case is T 0 equal to 1. So we will get here, we will solve this as n minus k equal to 1. So we will get n equal to k. We substitute n into k. We will get T of n equal to T n minus n plus n. So we will get T 0 plus n, and we simplify it, will be T of n equal to 1 plus n. So the BO is O n.